over here, we're taking a look at a max-min question involving geometry. So we've got a circle. Inside this circle is a triangle, and it's split up. The center of the circle is here. It's split up in a few different ways. And we basically want to prove the area, as we generally do, find an expression for the derivative, and then find the maximum area, which of course means making the second one 0. So now that we know where we're heading, let's take a look at the details of the question. You've got this diagram, and O is the center. You've got a constant radius r because of the circle. Now, xy is a chord, but it's variable. What that means, of course, is that xy can move around. So xy could be there, or it could be longer, like there, or it could be shorter, like here. It could be anywhere. It could be moving around. But it subtends an angle of 2 theta at the center O. So that's theta and theta, due to circle geometry that they've already done for you. Its angle is bisected here. Let P be the point on the major arc xy, so that xp y is isosceles with xp equals yp, okay? Let drawn in, so these two are equal. PO meets xy at M, this point here, and it's a right angle as drawn in for you, so that PM is perpendicular bisector of xy. So all the details are there drawn for you. And to be clear of what we mean by xy can move around, if xy was on the green one, then theta would be a bit bigger, and P would still be there, okay? So that would be what that would look like. And if it was blue, then it would look like this, okay? So basically, that's why we're saying xy is not fixed as it moves around. You're going to get a related construction in all those cases. So the first thing we're asked to do is prove the area is related to this function. Okay, so rather than draw out the diagram, let's just think of how we get the area of pxy, which, if you like, you'll recognize is this triangle here. Well, with it being that triangle there, it probably is not too hard to see that you can split this up into a few different triangles. The yellow one, the blue one, and the green one. So what I'm really saying is the area of triangle XPY can be thought of as the sum of the area of, so I'll just leave out area, but basically it's triangle POX plus triangle POY plus triangle XOY. Okay, so if we can work out all three of those independently and then add them up, then we should get the right answer. So triangle POY, well, as with any triangle, area of a triangle is half AB sine C. So if we just think of it focusing on the key length, which is R here and R here, so it'll be half times R squared times it's half R squared times sine of angle POY. Obtuse, right? And very similarly, triangle POX would be half R squared angle POX, which will basically be the same angle, okay? And for XOY, it will be half R squared sine of angle XOY, which is clearly half R squared sine 2 theta because just the way it's drawn out for you. So that one's easy enough. But angle POY is probably quite clearly just, if this angle here is theta, and we focus on the fact that there's a straight line going down here, well then if that's theta, then that's 180 minus theta. So this is really half R squared sine of 180 minus theta, or we'll use radian, pi minus theta. And we know from our trig expressions that that's really just going to be theta. Well, sine of 180 minus theta is just theta. And so this will be the same because it's also 180 minus. So what I'm really saying then is that this is really half of r squared sine theta plus another half r squared sine theta plus half r squared sine 2 theta. Well, half r squared sine theta plus half r squared sine theta is just going to give me 1 r squared sine theta. Now, sine 2 theta, though, is 2 sine theta cos theta, which means I'm just going to get r squared sine theta cos theta, meaning I will get r squared sine theta 1 plus cos theta as required. And therefore, we've done what they've required. They wanted us to prove that, and we're done. Now, once we have that formula, we can just move on to the earlier parts, which is pretty standard. We know how to do these questions. From here, you really just, one, take the derivative as they require, first and second derivative, and then show it's a max. So let's do that. We already have A is r squared sine theta, 1 plus cos theta. We will now want to derive with respect to theta, recognizing r squared is a constant. If r squared is a constant, then this is really a product. You're deriving with regards to theta. That's a function of theta. So is this. So you need to use the product rule. I'll do it directly, but you can use your u's and v's if you like. Well, firstly, you need to derive sine theta, which is going to be cos theta. And then you're going to multiply by 1 plus cos theta, the second one unchanged. You'll need to add the derivative of the second one. Derivative of 1 is 0. Derivative of cosine is negative sine theta. Times the first one unchanged, which is sine theta. And there's your derivative. That's your first derivative. A little bit of sort of simplification. So you've got cos theta plus cos squared minus sine squared. And they've specifically asked us to show that they want it in terms of cosines. So we'll do that. We'll change the sine squared. I mean, always keep in mind when you're trying to prove something what they want you to show. So they want you to show that it's this. So we've got the cos theta already. We'll just keep that. We've got a cos squared, but we don't have two of them, and we've got a 1. So what we basically need to do is we need to get rid of the sine squared. Okay? And you should hopefully be comfortable with the fact that sine squared is 1 minus cos squared theta. So that means r squared is cos theta plus cos squared theta minus 1 minus cos squared theta. And with a bit of algebra, you have that. So first derivative is done as required. Now, they also want you to find the second derivative. So the second derivative given that it's in this form, remember it's r squared, which is a constant, so you don't need to worry about that. Now, when you derive this, you're deriving with respect to theta, so you need to use the chain rule, okay? So it's 2, it's a constant, but you're deriving cos squared. So you're going to take the power down to cos theta to the power of 1, and then derive cos theta, which is negative sine theta. And then you need to derive cos, which is negative sine theta, and then derivative of negative 1 is 0. So that will be that. So we can take out negative sine theta, leaving you with 4 cos theta plus 1. And that will be our second derivative. So now we want to show that it has a maximum area when it's an equilateral triangle. Okay, so in other words, if you want to show that x PY that's really the question. If you want to show its maximum area when it's an equilateral triangle, think of what that means for you. So XPY wants to have a maximum area. You're trying to maximize this entire thing when it's equilateral. So you want the triangle in blue right now to be equilateral. Now, if that is equilateral, that means all sides are equal, obviously. But it also means all angles are equal. And if all angles are equal, then hopefully it shouldn't be a surprise that those will be 60 degrees. Okay. So if you want to show that those are 60 degrees, but recognizing that looking at the green triangles now, for the green triangles, we recognize that because this is R and this is R, then this angle must equal this angle. And therefore, if alpha is 60 degrees, and also looking at the yellow triangle, which is basically the same triangle over there, we recognize that, again, this angle here must equal this angle here. But at the same time, we also said that px equals py from the question, right? Px equals py. So that basically means that the bottom angles must be equal. We essentially get the fact that because this angle must also be equal, if this is beta, we're basically saying that beta must equal 30. If beta has to equal 30, then that actually then means, of course, that theta must equal 60. We're basically saying that as a result of this, if this is 30 and that's 30, you can look at it in terms of angle sum of triangle. If that's 30, then that has to be 120, which means this has to be 60. What I'm really saying is, looking at the diagram below, for triangle PXY to be equilateral, theta is going to equal 60. That's when it will happen. So basically, we're going to basically prove theta is going to be 60, all right? So we know dA d theta. We know A equals R squared sine theta, 1 plus cos theta. We know dA d theta equals R squared 2 cos squared theta plus cos theta minus 1. And we already also worked out the second derivative, which was negative R squared sine theta for cos theta plus 1. So our first job is to take the first derivative and let that equal 0. So for dA d theta equals 0, of course, R can't equal 0, otherwise you have no circle. That means you've got 2 cos squared theta plus cos theta minus 1 equals 0. Let's see if we can factorize this. So that means cos theta must equal a half, or cos theta equals -1. Of course, we can solve for these for all solutions and so forth, but for now, if cos theta equals a half, then we recognize that that would need to be pi over 3. Okay. For cos theta equal -1, that means it will be 3 pi over 2, or negative pi over 2. Actually, it will be pi. But if you take a look at your diagram again, it would make sense for theta to not really be, I mean, theta can't be pi, right? I mean, if it's pi, they're all pointing at P. So, I mean, quite clearly, you can have it being pi, but then the only thing you're going to get is just a straight line, which will basically not have any sort of triangle. So what I'm basically saying is, if you think about it being pi, if it is pi, right? If this is your O, and you're going to have this so-called pi, if you want the angle to be pi, which is 180 degrees, then what that really means is then your lines are going to go up. So yeah, you will have, it is possible to do that by the construction of the question, but you won't really get much of a triangle. And you'll get a minimum area triangle, okay? So clearly that's not the answer we're looking for. So we're going to be more focused on the answer here. So we expect, just thinking about it logically, that this is going to be a minimum area and this one is going to be a maximum area. But of course, we should be proving that. And our job is to prove that with a second derivative, which is why we did that earlier. So if we look at it from the perspective of whether it's positive or negative, which is what we want, you can use a calculator sub in to get the actual value. But this is the first quadrant. It's an acute angle. So cosine and sine are going to be positive. So cosine of the acute angle will be positive. You can work out the actual number. We know it's half. So we can actually work out the number, right? It's going to be 3. This bracket will be 3. But the point is, this bracket is positive. Sine of that angle is also positive. So we've got a positive times a positive. R is positive, but you have a negative in front. So what that really means is that your second derivative is going to be negative. Okay. You could sub in the value to get the answer. Okay, that's going to be 3, then 3 times your root 3 over 2. Okay, so it'll be that. But the point is it's negative. That's really what you want. On the other hand, if you sub in pi, then sine of pi will be 0. So I guess this is just 0. And it's really nonsensical anyway. So we're not really worried about that. Okay, we don't really care about that one. So therefore, we've now found that theta equals pi over 3 is when we've got our maximum. And we kind of already just said that that will then lead to the fact it's going to be an equilateral triangle, because now that we've got theta equals pi over 3, just quickly recapping, this is pi over 3. So this is pi over 3. This is 90 degrees. So this means this is 30 degrees, basically. Like, we'll use degrees, which I think people are generally more comfortable with. So if that's 60, then that's 120, which means this is 30, which means this is 30, which of course means that this is 60. Of course, the same argument could be made to the right-hand side, which means that that will be 60. And of course, that also makes that 60. And therefore, PXY is an equilateral triangle. And therefore, that's basically proven what they wanted. That's how you do the question.